students, so welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today is Sunday, and as every Sunday we conduct mock tests. So today we have conducted the mock test for the PU2 whole organic chemistry series, and like I hope all of you would have attempted it, downloaded the question paper. So students, please do not ignore the mock test. These are very important to check your progress, and so at least from now onwards you should be very regular in attempting the mock test. Okay, so yes, so we'll be now discussing the solutions. If you haven't downloaded the question paper, it is available in our WhatsApp channel and in our community post of the Diksha Karnataka YouTube channel. Okay, so please download from there, solve it, and then watch this video. And after watching this video, please assign yourself the marks and do not forget to comment down your scores. So yes, now let's get started with the first question. Okay, so which of one of the following chlorohydrocarbon readily undergoes solvolysis? Okay, so for this you should know that solvolysis follows SN1 mechanism. That means it involves the formation of carbocation. So wherever there is a stable carbocation formed, that will be reacting fastest, right? Or it will undergo the reaction readily. So you can see, if I remove the chlorines, then here a carbocation will form, here carbocation will form, here carbocation will form, and here carbocation will form. Now you see, this is a benzyl carbocation, resonance stabilized, so this is the most stable carbocation, so it will undergo solvolysis readily. So correct answer is option number A. Next, identify the products A and B in the reaction. Very simple, you know, KCN adds CN and AgCN adds NC, that is isocyanide. So A will be RNC, we can eliminate these two, and B will be RCN, so option number A. Okay, next we have this one, bromination. Okay, bromine in UV light, so it follows free radical mechanism, but a stable radical will give you the product. So here, if this bromine can replace either these three hydrogens or these two hydrogens, right? So like any one of these three hydrogens or any one of these two hydrogens. Now here, if it is replacing a secondary hydrogen, much more stable radical will form here, so one of these hydrogen will be removed. So if you see, this is not correct here, yes, this is correct, option number B. Okay, next, the major product in the following reaction is, yes, this is important question. Now major product is asked, so if you want to find, first HBr will happen, HBr will be added, so that will be following Markovnikov's rule. So what will I get here? CH2 CH2OH. okay, now when you are adding HBr, here H will be added and here Br will be added, following Markovnikov's rule. Next, if you add further HBr, then what will happen? This HBr is there, okay, it will take this one, so I will get here CH3 CHBr CH2 O plus H2. First it gets protonated and then this Br will attack here, right, and this one will go. So I will get CH3 CHBr CH2Br. okay, option number A. Many of you might mark option number C as the correct answer, because here you do not think that here HBr is present in excess, so that will also remove this OH group. Okay, A will be the correct answer. Okay, next, which of the following halides undergo hydrolysis on warming with water and aqueous NaOH? So here we know that haloarenes do not undergo hydrolysis easily, but if you give more number of electron withdrawing groups, the reaction can happen. So here you can see there are 3 NO2 groups are present, 3 electron withdrawing groups are present, so definitely this one will be the one which is reacting. Okay, next, this is an important question. 8.8 gram of monohydric alcohol is added to ethyl magnesium iodide in ether, and it liberates 2240 centimeter cube of ethane at STP. This monohydric alcohol, when oxidized using PCC, forms a carbonyl compound that answers silver mirror test. The monohydric alcohol is, okay, so this is also very important question. Now you can see here what happened. You have a monohydric alcohol, that means that alcohol has only one OH group. Okay, Now when you add this alcohol with ethyl magnesium iodide, so how do the alcohol reacts with Grignard reagent? See, this is suppose alcohol and you are reacting it with Grignard reagent, ethyl magnesium iodide. So CH3 CH2 Mgi. Okay, then what will happen? Plus and minus you need to do, right? O minus H plus Mg plus CH3 CH2 minus. So this minus will take this plus and this minus will take this plus. So what is the product formed here? I'll be getting CH3 CH3 and then here the product formed will be ROMGI, right? So what gas is produced here? Ethane gas is produced. Okay, that is the first thing that is told. Now when this monohydric alcohol is oxidized using PCC, forms a carbonyl compound. So when it was oxidized with PCC, it formed a carbonyl compound, means either it can be a ketone or it can be an aldehyde. But the next statement is saying that answers the silver mirror test, means your tolerance reagent, right? So that is given by only aldehydes. So this is not a ketone. This carbonyl compound that is formed after oxidation is your aldehyde. Then if this is on oxidation giving you aldehyde, then I can say about this alcohol that it is a primary alcohol. Right. Now if you see here options, butane 2-OL is a secondary alcohol, we can eliminate this option. Pentane 2-OL is also secondary, so we can eliminate this option. Okay, fine. Now what we can see here, that we are, how much ethane is produced? 2240 ml of ethane is produced. Okay, then can I tell in terms of moles? So how many moles of ethane produced? Moles, so that is given volume by molar volume, 2240 ml, okay, divided by 22,400. Okay, so that will give you how much? 1 by 10, or I can say 10 to the power of minus 1 mole. Okay, okay, if 10 to the power of minus 1 mole is formed, now let us calculate the molar mass of the compound. Okay, so we have number of moles is equal to given mass by molar mass. So molar mass will be equal to given mass by number of moles. Okay, so what is the given mass here? Given mass is 8.8 and number of moles is 0.1, so that is 88 grams. Okay, we got 88 grams here. So now what you need to do is you need to calculate, check these two options and check whose mass is coming, 88 gram. Okay, so molar mass should be 88 gram. So if I see 2,2-dimethyl propane 1-OL, so I have like this, 2,2-dimethyl, okay. Fine. So if I see now, I have 1, 2, 3, 4, 5 carbons, right? So 1, 2, 3, 4, 5. So 12 5s is 60. Okay. Next, how many oxygens are there? 3, 3, 3, 9, 10, 11, 12. So again 12 oxygens and oxygen is 16. So if I add this, I'll get 88. So yes, 2,2-dimethyl propane 1-OL is the correct answer here. Okay. Next, compounds P and R in the following reactions are. So it's a reaction is given and you need to identify P and R. Okay, so first of all, if you CH3CHO is there and you are adding CH3MgBr, Grignard reagent is added, nucleophilic addition reaction. So the product formed here will be right. So the product formed here, we will have CH3, C double bond OH and one more H is there. So this is your P, right? Then concentrated H2SO4, if you give, what will happen? There will be dehydration and we will get propene, right? So propene will get, that is your Q. Okay, next we get B2H6. Now B2H6 add H and OH following anti-Markovnikov's rule. So if I add this one, I'll get CH3, CH2 and CH2OH, right? So now if you see here, OH is coming in the second carbon and here OH is present on the first carbon. So that means what? Now these two are your positional isomers, that is option number A. Okay. Next, question number 8. The heating of phenyl methyl ether with HI produces an aromatic compound A, which on treatment with concentrated HNO3 gives B. A and B respectively are. So if you have phenyl methyl ether, okay, now with HI what will happen? Definitely whenever the phenol is there, bond will break like this and we will get here phenol and iodomethane. Okay, so we will get phenol and I need, okay, after that the question is still there, compound A which on treatment, okay, which on treatment with concentrated nitric acid gives B. Okay, so if you treat concentrated nitric acid, here all the three positions will be occupied with NO2 group and we get picric acid. So phenol and picric acid, that is option number D. Okay, so let us see the next question now. So you need to find out the product here. Okay, the Y in the above reaction is, so if you see what is A will be, first you will have phenoxide ion. Okay, then if you are treating with carbon dioxide, then you will get O minus, Na plus and COO minus, right? Then like it can be protonated and you will get like this, one second, OH, COOH. Then if you do acylation, we will get OCOCH3 and COOH. Okay, so this is called as aspirin, option number B. Okay, next, okay, this is question number 9 again. Question number 10 is, among the following the products formed by the reaction of anisole with HI. Okay, so anisole with HI, the same thing, you have OCH3, right? So here the bond will break and we will get here phenol and I will be added here, that is iodomethane. Okay, so phenol and iodomethane, option number C. Okay, next, among the following the products formed by the reaction of anisole with HI, again this question is repeated, so option number C, phenol and iodomethane. Okay, next, one second. Okay, so when the vapors of tertiary butyl alcohol are passed through heated copper at 573 Kelvin, the product formed is, okay, so tertiary alcohols, if you remember, at 573 Kelvin will give you alkene and that is why the product formed here will be butene. So if you see tertiary butyl alcohol, CH3, CH2H, I am writing like this so that I can show you the dehydration process. This part is removed and here a double bond will come. So sorry, this one will give you 1, 2, 3, 2-methyl propene. Okay, so 2-methyl propane will be the correct answer, option number C. Okay, next question, Y can be obtained by Etard reaction. Okay, Z undergoes disproportionation reaction with concentrated alkali, then X could be. Okay, so if Y undergoes Etard reaction, Y can be obtained by Etard reaction. So if you remember, Etard reaction product is what? Benzaldehyde, right? So Y can be obtained, Y can be obtained by Etard's reaction. Okay, Z undergoes disproportionation reaction with concentrated alkali. Okay, if Z is undergoing if Z is undergoing disproportionation reaction with concentrated alkali, that means it is a Cannizzaro reaction, right? So Z should be something which is which is not having alpha hydrogen. Okay, and if you remember, we can obtain so Etard reaction is the product giving you what? Benzaldehyde. So anything, so I can say that Y should be something, Y is nothing but your benzaldehyde. Okay, and Z is a compound with no alpha hydrogen, and X on ozonolysis should give you these two products. So if you see here in option number B, okay, if you break the bond here on ozonolysis, the products formed here will be COH, which is a product of Etard reaction, and that side we will get formaldehyde, right? Now formaldehyde will give you what? Cannizzaro reaction, and this is the Itard reaction. Option B will be the correct answer. Next, iodoform can be prepared from all except. So for iodoform the condition is what? It should have CH3 C double bond O group, either this should be present or CH3 CHOH, this has to be present. Okay, so now if you see butane 2-ONE is having that, acetophenone is having, propane 2-OL if you check, that is also is there, propane 2-OL, we have CH3 CHOH, then CH3, right? So this group is also present, so this one will show. Now propane 1-OL will not show this reaction, so correct answer is option number D here. Next, predict the product C in the following series of reaction. Okay, so first you have PCl5. Okay, so we have CH3 C double bond O. Okay, C double bond O, then ClOH will be replaced with Cl, that is your A. Next, if you have C6H6 benzene diazonium, C6H6 with this one, so this is your Friedel-Crafts alkylation, we will get COCH3. Okay. Next, if I react it with CH3 MgBr, so what I will get here? We will get COH, CH3 and CH3. Okay. So what will be the product here? C6H5 COH CH3 whole 2. Option number D. Next, in the following sequence of reactions, you need to find the end product C. First CH3Br is there, with KCN it will give you CH3Cn. With H3O plus it will give you CH3COOH. With LiLH4 it will be giving you reducing agent CH3CH2OH. Okay, so that is ethyl alcohol, option number B. Next, propanoic acid undergoes HVZ reactions to give chloropropanoic acid. The product obtained is stronger acid than propanoic acid. Yes, definitely here one electron withdrawing group is present. Electron withdrawing group will definitely increase the acidity by stabilizing the conjugate base. Okay, so that is why option number A. Okay, next, this is a very important as well as interesting question. Okay, now if you see, first of all, what first one in this product, what is happening? CHO group, so CHO group is converted to CH2OH, right? So that means what? Reduction is happening. So for reduction we need NaBH4 we can do. So here NaBH4 is present, here NaBH4 is present. Now why can't we use H2 palladium? If you use H2 palladium, this double bond will also get reduced. Okay, so that is why we cannot use, can eliminate these two options. Next, you see what is happening. CH2OH is getting oxidized to CHO. Okay, so in this case, if you use alkaline KMnO4, it will get oxidized to acids, right? Primary alcohols will convert to acids, but here we need only mild oxidizing agent, so PCC will work. So this is also incorrect. After that, if you use H2 palladium, so that will reduce this one as well, the double bond. So that is why option number C is the correct answer. Next question, the reagent which can do the following conversion. So we have the reduction of acid group, that will be done by lithium aluminum hydride, option number A. The test to differentiate between pentane 2-ONE and pentane 3-ONE. So pentane 2-ONE is having your CH3CO group, so it can be detected by the iodoform test. So you can see here pentane 2-ONE structure is like this. Pentane 3-ONE, we have pentane 3-ONE, right? So here you can see we have CH3CO group, okay, because this group is present. Now what it can do, it can show the reaction, so iodoform test will happen here. Okay, next we have PQR respectively, you need to guess. So first of all, NH2 to N2Cl minus, it is your benzene diazonium chloride is getting formed, right? For that what we need? NaNO2 into dilute HCl. So here it is concentrated HCl, remove this option. Next we have added BF4 minus. For that we need HBF4, so that is only present in this option, so option number A will be the correct answer. Okay, next C6, so this is ammonolysis question. So if you see C6H5CH2Cl is reacting with NH3, so in that case what will happen, one of the hydrogen will be replaced with this R group, right? So I'll get N, we have H, and rest will be this one, CH2, C6, H5. Okay, after that what happens, again we are treating with 2CH3Cl, so that will replace this all the hydrogens with CH3 group. So what will I get, NN dimethyl, okay, so this option is wrong. Phenyl ethanamine, benzenamine, yes, so this is a phenyl group, ethanamine, option number A. Okay, next NO2, then Br2 and FeBr3. So what it will do, it will do bromination at the meta position, right? So we have NO2 and Br. Next after that SnHCl, so SnHCl will convert NO2 to what, NH2, right? Reduction of NO2 takes place to give you NH2. This is your Q. Now if you treat it with NaNO2 dilute HCl and then warm with water, so first this one will give you benzene disonium chloride. So once we heat this, we will get benzene disonium chloride, and after that if you warm it, we will get phenol here, right? So I'll get OH and Br. Okay, so correct answer here will be option number A. Okay, next the reaction of benzene diazonium chloride with aniline yields yellow dye. The name of the yellow dye is, so you have benzene diazonium chloride, okay, with aniline, right? Okay, so when these two reacts, the product we form is a dye, that is your coupling reaction, and we get like this. Okay, so that is your para amino azobenzene, option number B. Okay. Okay, next question, which of the following is more basic than aniline? So if it is more basic, it should have electron donating group, right? So you see diphenylamine, triphenyl, these all are electron withdrawing groups. Benzyl amines, if you see, benzyl amine is like this, right? So the lone pair of electrons here are present, and this can be donated. This is not involved in resonance, so these lone pair of electrons are easily available, so that is why option number D will be the correct answer here. Okay. Okay, next alpha D glucose and beta D glucose are your anomers, so option number D. The glycosidic linkage between sucrose is C1 of alpha glucose and C2 of beta fructose, option number A. Okay, next the correct match. So vitamin A is your night blindness, so A has to be 3, so we can eliminate these two. Then vitamin D osteomalacia, that is 2, has to 4, so option number D here. Next, hypothyroidism is caused by the deficiency of thyroxine, that is option number B. And next, primary structure in a nucleic acid contains bases GATGC, the chain which is complementary to this. So GATGC, okay. Complementary means you should know here, A forms bond with T, G forms bond with C, right? So GC, then AT, TA, GC and CG. So CTA, CG, option number C. Okay. So yes, students, that's all. We have discussed all the solutions. I hope you have done it well. So please count your marks and then do not forget to comment down the scores. Let me know how many of you have prepared really well for the test. Okay. Thank you for watching. Please do not forget to subscribe the channel and see you soon in the next class.